Okay, let's go ahead and start chapter 1, section 8. This is all about introduction to solving linear equations. Um, I don't know if solving is a word. I should say simplifying linear equations. We're not really solving equations yet. We're just kind of simplifying them, putting like terms together, more or less. I should probably rephrase that. But anyhow, part 1, let's go through some notes here. So each part of an algebraic expression, each little part of it, those are called terms. I might have mentioned that before. The numerical factor of a term is called the coefficient. Right? What I mean by that is like if you have something like 15x, something like that, the coefficient is 15. All right. The whole thing, the whole thing is called a term. All right. But the 15, the number that's in front of the letter, that is called the coefficient. All right. Next, if an expression contains um, the same or equal, I guess, but the same variables and powers, the terms are called like terms, which we're going to focus on a lot in this section. All right, so like terms. So that means like some examples of like terms would be 3n, 17n, and just n, those are like terms. They all have the same variable attached to it, okay? Those would be it. All right. What else is an example? You might have like 25a squared b, 20, I don't know, or just 2a squared b. Those are like terms because they both have a squared b, right? They don't have to have the same coefficient, that's for sure. They just have to have the same variable terms. That's the part you're looking for, right? A term does not have a variable. It is if a term does not have a variable, sorry, it is called the constant. Okay? Examples, like some examples of constants, like 31 is a constant, like January has 31 days. There's 26 letters in the alphabet. That's a constant for sure. um, I mean, as long as it's a number, it doesn't have to be like associated with something. Uh, 4 is a constant. A negative number, -9 is a constant. 0 is a constant. All right. So as long as it does not have a letter attached to it, or a letter, I say attached to it, but doesn't have to have a letter like as a factor of it. It is called a constant. All right. So some examples. So let's kind of go through these. This is a good one where you can kind of pause it and just kind of go through this on your own, fill it out, and make sure you know it. All right. But for what we got here is for this one right here, the terms are just kind of everything. So 4x, 12, and x. Those are the terms. Now the coefficients are -4. And now if it's just a letter, we can assume there's a 1 there. So the coefficient of x is 1. All right. The like terms are -4x and 1x. All right. I should just put x, and the constant in this one is 12. Okay. That's that. All right. This one right here are the terms. I'm just listing them out. So 6n, -7n, -4, and n. All right. The coefficients are 6, -7, and this has got a coefficient of 1. All right, the like terms are 6n, -7n, and n. And there's one constant in there, -4. All right, this one, the terms are 9y, -4, -11y, and 7. The coefficients are 9 and -11. The like terms, now I'm going to write them like this. The like terms, there's a couple pairs of like terms. So we have 9y and -11y. Those are like terms. I'm going to circle those because those are a group of like terms. And the constants are like terms as well. -4 and 7. That's a pair of like terms. All right, so the constants in this one are -4 and 7. All right, this one, we've got lots of terms. We've got 8d, 2f, -10, and -3x. The coefficients are 8 right here, but the one that's attached to the d. 2 is a coefficient. This is a constant, it's not a coefficient. We've got -3 as a coefficient. This one has no like terms. I'm going to put none. None of them are like terms, but there is a constant, which is -10. All right, moving on to the next page. Let's go ahead. An algebraic expression is in simplest form. Simplified, Oops. It's in simplified form if it has no like terms and no like constants, which are like terms too. A little bit redundant, but I'm going to write down. So like constants. If needed, use the distributive property to clear out all the parentheses if they're there. Not every problem will have parentheses, but they sometimes do. All right, so for these practice problems, we've got to write these in simplest form. It says also, what is another way to express the d term? I kind of talked about this, but another way to think of d or any just lone variable term like x or n, or in this case it's d, is just pretend there's a 1 in front of it. So 1d. Think of it as 1d. All right, so you can think of that as 1d, which makes it easier to put those together. So you got 4d plus 1d, which makes 5d. And that's all you can do. That's all there is. You can do that one right here. These are like terms. All right, 9h and 7h makes 16h. Okay, and the constants are also like terms. So that makes 8. 2 plus 6. So 18h plus 8. And like I was talking about earlier, that's all you can do to those. Excuse me. That does not make 24h or anything. It's just 16h plus 8. That's all there is. Can't do anything else to it. All right. This one, what do we got? We've got the x's. We got 4x and 4x. That makes 8x. Okay, we've got the constants, 11. We've got 5. That makes 16. All right, and so that is 8x plus 16. Kind of looks like the last problem we did. All right, right here. Now this one, are there any 8 ends? Are there any other ends? No, I don't see. Are there any other constants? I don't see any others. Constants, I don't see any other p's. So this one is already in in simplest form. I don't know why I have to rewrite it again, but that cannot simplify any further because there are no like terms to it. All right, now solving equations using mental math. Okay, so yeah, we are going to solve a little bit of equations here. Just kind of using a guess and check, intuitive mental math approach to it. So two expressions here. I'm going to write down what the meaning of an equation is. Two expressions separated by an equal sign is called an equation. All right. So what we have for A here, what it says is a number, right? What number, what value, what number plus 9 equals 25. That's essentially what it's asking. What number plus 9, plus, what number when you add 9 to it makes 25. And you can, you probably already know this, but you could try, you can guess and check. All right, is it 10 plus 9? No, that makes 19. Is it 20 plus 9? Well, that makes 29. All right, so you already know that it's between 10 and 20, right? Between 10 and 20. So you could probably figure out where it's going, it's 16, right? 16 plus 9 is what n equals. So 16, right? 16 plus 9 equals 25. Pretty simple, right? Pretty simple. All right, so this is what number times 15 equals 90. That's what we're essentially asking on this one. And again, you can kind of just take a guess and check approach, like 15 times 4, is it? Well, no, 15 times 4 is 60, Is it 15 times 8? Well, 15 times 8 is 120, right? Double that of what 4 is. So it's definitely not 8 is too big, and you eventually you'll arrive. Oh, it's 6, right? So 15 times 6 is 90. All right, so right here you got what number? Which number divided by 14 equals 7? And you might look at 14, you might look at 7 and automatically deduce. You're like, oh, that's 2. Division, 14, 7. But no, that's what number divided by 14 is 7. So I mean, even if let's say we start off, this is an obvious wrong answer, but like 14 divided by 14, that equals 1, right? So 14 divided by 14 does not work. 28 divided by 14, that's 2, right? So I can keep going up and keep going up and up and up and up until you get to the answer. I'll just spoil it for you. It's 98, right? So that's it. All right, so right here, what number times 9? Times 9 increased by 8, right? Or plus 8. Equals 53. That's what's going on there. So what number times 9 increased by 8 equals 53? And again, we can kind of just guess and check our way through this. So you got 9. Maybe it's 9 times, maybe it's like 9 times 8. I'm obviously, I'm going to use like wrong numbers on purpose just to kind of show you kind of the guess and check process. But yeah, 9 times 8 is 72, right? 72 plus 8, too big. That's 90. We want 53. All right, so 9 times what? 9 times 5, isn't that what it is? 9 times 5 plus 8. Is that equal to 53? Well, 9 times 5 is 45, right? 45 plus 8, you guessed it, is 53. So W equals 8. That's the value of W that makes that true.